G'day everybody and welcome back to the amplifier design process and welcome back to the channel. Like I said, the last couple of videos I had experimented with a few different circuits and I am pretty confident now with a mixture of those circuits and combinations of things I can get this perfect. Now, to save time for the video, because my videos have been getting quite lengthy, so I'm trying to slowly start learning editing, finally. I know I said I was doing it a while ago, I finally am. And I'm also trying to make my videos a little bit more information crammed into less time, just to make it easier on you guys. Anyway, so without further ado, what I've done, let's just go over to the screen first, because it will make a lot more sense if we start here. Now, sorry, my apologies. As we all know, I tried putting a current source here, just ignore that transistor, but that turns that into a collector amplifier. You get your varying Miller multiplication and it buggers things up. If you do this and compensate between here and here, whether that transistor is there or not, you don't get that problem. So I thought, well, what if I do this? Ignore this transistor, or ignore this transistor, just pretend this goes to here, and that's not there, right? What if I change my two NPNs, beta enhanced transistor, leave that NPN there, change that for a PNP, current source in the top, and the 470 ohm resistor that we worked out is the perfect value in the bottom, plus the regulated sub rail running off the VBA multiplier, kind of like what this person's done at the bottom of their amplifier on the negative rail. They've added a bit of filtering. It's not a really refined VBA multiplier like the one I built, but you know, this amp's supposed to be like all the bells and whistles, so obviously I'm taking everything the whole way. So what I've done, I've fitted not the GR category, the BL category, the high gain A1268, the counterpart of the C3200 that was in there. I've rearranged this so it's no longer a current sink, it's now a PNP current source. So basically have I done that wrong? Sorry, I might need to think about this for a second. My apologies, I just need to pause the video. Alright, as I understand it, we're not going to be taking the signal off the emitter anymore, so the emitter resistor will still be here for this. But where you've got the PNP current source going into the PNP transistor, is that right? I just feel like I'm buggering something up here. Hold on, let me just look at my diagram one more time. Sorry, my apologies, guys. I am prepared. I'm just having a bad brain moment. PNPs. PNP. Yeah, I know what I'm thinking. Sorry, I got a little bit confused there. So, the collector of that is going to go to the collector of that. I've done something wrong here, haven't I? Oh, I know what I've done wrong. So, my bad. The collector of this current source, which is 1.3 milliamps, needs to go to the emitter of this transistor. These are both PNP transistors now. So the collector of this current source needs to go to the emitter of this transistor, which is here. Its collector will have a 470 ohm resistor going to the rail. Yep. And off the emitter, where wait, so we're still going to be okay. So what I need to do is I need to move this black wire that supplies the current to the emitter. I need to move the emitter resistor to the collector. Hope that makes sense. Let me just, I think I've already drawn this out on paper. Let me just make sure I've done it correct. So PNP current source goes into the collector of the PNP transistor. It's got its emitter resistor. The collector then goes into the base of the VAS transistor, which has got the bias network and its current source, and that drives the push-pull for the pre-driver, driver, and output stages. And this is my modified capacitive multiplier circuit, which will drive the subrail. So this is my solution so far. So this is the first thing I'm trying. Like I said in the last video, now I've got all these different circuits and ideas to try. That's what we're going to do in this video. So let me just, let's see, leave that 100 ohm resistor there for now. It's not really in the way. What I'll do is I will take this 470 ohm resistor and I'll just move it over to the collector, just temporarily. That'll do. So now the emitter goes straight into the next stage. Collector's got a 470 ohm resistor going to ground, and our current source is now going to the pad where the emitter resistor used to go, because now that's where we're supplying the current. PNP current source is going to the emitter of the PNP beta enhanced transistor, which was an NPN. Yeah, it might have a little bit less gain set up this way, probably not, because it's got a current source on top of it. It's going to have extra gain, so actually it's probably going to be quite beneficial. I actually like stacking transistors, either full complementary, push-pull, or NPN, PNP, NPN, PNP. If I'm building amplifiers, I like to keep stuff as symmetrical as possible, so I actually quite like this idea. First thing I'm going to do is I'm going to remove the current source. Let's disconnect this for a sec. And I'm just going to power the amp up, just hooked up like that with that transistor in there, but with no power being supplied to it. Hold on a minute. Its emitter has power, but its collector doesn't. Should be alright, I think. Yeah, because, sorry, no, its collector goes to the rail, so its emitter's got no power. Should be right. Let's just power it up and see what happens. Okay, so yep, that's going to work. As you can see, that's passing the signal through without this transistor powered. Neither the resistor or the transistor are hot. We don't have any offset or anything, so it's wonderful. I don't even have the subrail on. There's the subrail. Beautiful. Turn the subrail back off for now. Alright, let's add the current source. So what I've done is I've set the current source up just to show everybody what we're running. So about 1.3 milliamps. Like I said, just shy of 1.5. It's a really good area for this transistor to have good gain, but still not to the point where the current's so low that it can't drive enough. I already worked this out. This current level and a 470 ohm resistor to the rail was basically perfection in terms of stop. Oh, fuck. Why do I do shit like this? I just popped a nice 2N5551. Remember before I was using those Chinese ones? The real ones have arrived now. Just pop the real one. It's alright, I'll go grab another one. I'll be back in a minute. But we'll hook this up and see how it goes. Alright, that little problem's solved. I've replaced yet another LED and transistor. Turn this back on. Good, it's running. Let's apply a current source and see if this doesn't go bang. Actually, I've just realised something. Something's already not right because the LED is not lit up. Oh, I haven't put power to it. That would make sense. Alright, let's now put our 1.3 milliamp current source in. Ah, that doesn't work. Not good. Not good. Damn. Maybe I need to follow it with another transistor, and that's what I was trying to avoid doing. I'm going to have a good think about this. There has to be a way around it. Can you get down? Please. Wow, that definitely doesn't work. I'm just trying to think. Get down. Seriously, I'm working. Picking up off the ground rail, supplying current to the emitter. I wonder if I should try running the current source from the positive rail and reference it to the ground rail instead of between the ground and negative rail, sort of like what they've done in their app. Maybe that'll give the transistor more swing as well. I'm not too sure. But all I know is if I try and hook this up, yeah, no chance. Anything get hot? That resistor got hot. Okay, so that was drawing a bit of current. Let me get this cat out of the room. It's causing me massive problems. Alright, cat's gone. Put the broken components in the solder tray. I am kind of upset that didn't work. Let me just have another think about this and make sure that I didn't do something wrong where I swapped the emitter resistor location and all that around. I've got a feeling that this is correct, but one moment. Alright, before I get too far ahead of myself, what I think I'm going to do, with the current source out, this is going to get a bit confusing. I know I've still got this hooked up with the collector getting powered from the current source. With the current source, sorry, not hooked up, so I'm getting tired. I'm going to have to call this an end to the night soon. But what I'm thinking is I take the wire that goes to the ground rail and run it to the positive rail, and take the negative rail reference wire and put that to the ground rail. So ground rail is going to go where the negative reference goes, and then this is going to go to the positive rail. Alright, so now we've still got our power source to go in the collector of the current source, but the current source is now referenced to the 0 volt rail and gets its power from the positive rail. Current source is still going to work the exact same way, but this transistor is now sitting in the midpoint between the two rails, not between the 0 volt rail and the negative rail. Is this going to work? I have no idea. Let's find out. Alright, no offset. Let's hook this up and Hope nothing goes bang. Oh, jeez. Talk about nothing going bang. Oh, that current just went all through that transistor. That wasn't good. That was a 1K resistor that just went up in smoke. I'll get another 1K resistor and then verify that current source is still working. Oh, well, it's not now. Oh, we might be able to redeem this. Let's just take this out. Oh, come on. Wonder if that 1K resistor is still a 1K resistor. Not quite sure why that happened though. Okay, I'm going to go back to the way I had it set up. Alright, so I tested everything out. It's all good. I think maybe that 470 ohm resistor might have heated up just a little bit, but I don't see any burns on. Oh, I see where the burn is. Okay, this resistor here got a little bit hot, but because it's only 47 ohms compared to the 1K that got cooked, it's fine. It's barely changed color, just a little bit on one side. I'll change that later, that's fine for now. Alright, so back to this. I've still got the PNP transistor in here. I'll turn this back on. Yep, still working. I'll put the sub rail on. Try and hook this up with the sub rail. No, same problem. The thing I don't understand, if we look at this, right, let me just turn these supplies off. So if we look at here, we can basically ignore this transistor because, you know, it's an emitter follower. What's this doing? Okay, it's getting taken off the collector, but I mean, signal's going in here, out here, signal's going in the base. What I don't get is, why can't I just eliminate that transistor and connect that junction to here with my current source there on the emitter? So this isn't an amplifier. We don't have our varying millicapacitance, and compensate like so. There's something I'm missing. Maybe this will only work with that extra transistor in there. But, I mean, that just totally defeats the purpose again. The whole reason I'm doing this is, you know, to not add extra components in the audio path. So I'm really confused. Why can I not make this work? I'm supplying my power from the current source at this node here. This is going to a 470 ohm resistor to ground. And this is essentially this transistor. Let's take another look back over here. That's the base. That's the collector going to the resistor to the negative rail. And the emitter goes... Oh, I see what I've done wrong. Hold on a second. No, that's right. Yes. The emitter goes to the base of the next transistor, and the emitter also goes to the current source. So, again, I'm confused because it's the same problem I had when I was trying to add something in the top. I remember as soon as what was it? No, current sink in the bottom. Whenever I put a current sink in the bottom, as soon as I powered it, I had this problem. Now I'm trying, you know what, it's got something to do with this emitter junction node in the circuit, because that's the same node both times that has obviously been affected by putting a current sink in here. And I've gotten the same problem both times. I'm going to have a little think about this. I might actually just upload this video here and see if I can get some feedback on it, because essentially this is what I'm trying to do. Alright, that's the pull driver, the push driver, the bias network, the constant current source, the fast transistor, the negative rail, the awesome capacitive multiplier to run the negative rail, which will be running from, say, an extra minus 5 volt sub rail with its 2 volts drop or whatever. There'll still be 3 point something extra for the minus sub rail. You know, current source from the 0 volt rail going to the collector of the I've drawn that wrong. That was the way I was originally going to do it, and then I realized that that was probably not correct. Yeah, that's not correct. What am I saying? Let me just redraw that. All right, my apologies. That's what I'm trying to do. Without adding that extra transistor in here, that's, you know, it would be going from the 0 volt rail. I just don't understand why I can't get this to work. If anyone's seeing what I'm missing, please put it in the comment section, because I really want to get this to work somehow. I'm sure you guys can tell. And I won't give up until I do. And you know, if it ends up being too hard and I just can't make it work, what I'll do is I'll put the VBA multiplier on the sub rail, the 470 ohm resistor there, a cap multiplier on the collector, see how much current goes through that transistor. It's probably going to be too much, actually. I don't know. Might try the current source in the collector, do a frequency response and see if it actually does millimultiply that many times. And if that's no good, then I guess we'll just have to go back to capacitance multiplier here, capacitance multiplier here, higher value resistor on the emitter with an NPN there, and a Baker clamp. And then I'll just have to start another amplifier design where I do a fully complementary VAS with current sources in both directions and sort this problem out. But I really want to get this to work, so I'm going to stop, have a little think about this, and maybe try one more thing, and then I'll upload this video and hope I get some feedback on why I can't seem to make this work. Why I can't seem to make this work with this eliminated, just that going straight to there. Alright, I'm going to try one more thing. I've had to think about it with the PNP transistor. If I take the current source out of its emitter that's feeding it from the 0 volt rail, move the 470 ohm resistor from the 0 volt rail to the emitter, and then reconfigure this circuit with a NPN transistor, turn the LED and capacitor around the other way, and reconfigure it so it's hooked up as a current sink. Going from the collector to the negative rail. That's the only other thing I can think of doing. Although, no, if I do that, then I'm just turning into a collector amplifier. Yeah, I'm going to leave the video here. I think what I'm going to do, unless someone in the comment section has an idea of how I can make this work without the third transistor in there like in the LM2907, I think what I'm going to do is tomorrow I'm going to put the 3200, the NPN, back in here. I'm going to put the capacitive multiplier on the collector, so it's got its rejection from the... sorry, no, not the capacitive multiplier. I'm going to put the capacitive multiplier and the subrail on the subrail. I'm going to put the current source on the collector and the 470 ohm resistor on its emitter. Like I did it before, which made it work perfectly, but that could cause varying multiplying millicapacitance. So I think if I can't get this to work, I'll do that, and we'll do a frequency response plot and see if it does actually affect it. And then if it does affect it, I'll see if I can compensate around it and get a flat response. Because if I can do that and make this work, that would be wonderful. If not, then what I'll do is I'll put a capacitive multiplier circuit, the one I designed, in the collector, still have an NPN, higher value emitter resistor, Baker clamp, and the VB multiplier on the negative rail as well, and the sub rail, which means the Baker clamp with all that other support stuff won't need probably to be straight across. I'll probably be able to get a resistor in series with it too, which is pretty good considering I'm already going to be using a Bass 21K if I have to. So leave it in the comment section if anyone can come up with a way as to why a reason as to why I can't get this to work with, you know, the PNP there driving the NPN. Leave it in the comment section. Otherwise, I'll continue playing around with this in the morning, and if I can't get it to work, like I said, I'll just go back to this other idea that did work without a Baker clamp, analyze it, see if I can get it to work without, you know, multiplying capacitance problems and dips and peaks in the frequency response. And if I can't, then we'll go back to the Baker clamp way with the sub rail and cap multipliers and all that sort of stuff. Alright, that concludes the video, so thank you everyone for watching, and your feedback is mostly appreciated. And if you haven't already subscribed, please do so, and hit that like button. Thanks for watching everyone, and I'll see you all tomorrow.